Welcome to the Uptime Wind Energy Podcast. Leading edge erosion is a massive power losing problem for most wind farms. Almost every wind turbine blade that has been in service more than 2 years has some level of leading edge erosion. I'm your host, Alan Hall, and I'm here with our guest, Nicholas Gaudern, CTO of PowerCurve. In this episode, we are discussing leading edge erosion, how it reduces average energy production, and when to address it for maximum revenue generation. And just a brief background on PowerCurve. PowerCurve designs, manufactures, and installs power upgrades for wind turbine blades that help their clients make their wind projects more profitable. PowerCurve's technology has been thoroughly tested and validated, and they continue to work closely with universities to refine it even further. And their upgrades have been installed on blades worldwide. Nicholas, welcome to the program.
Hi, Alan. Really nice to be back talking to you.
So you have some new software tools at your disposal, and anybody that knows PowerCurve knows you guys are really good at aerodynamics, understand how blades produce power. You want to describe what this little software breakthrough is?
Yeah, I'd love to. So what I want to talk about today is our new tool that we're calling AeroVista, and it's an API. You can call it. It does something, and you'll get some really insightful data back. Maybe just take a step backwards. It's all about taking a data-driven and an engineering-driven approach to understanding the performance losses that you will get from damages, and particularly leading-edge erosion on a blade. So we're about modeling those losses and telling you how you can deal with it.
Yeah, because there's a lot of information on the internet today. You see a lot of it on LinkedIn, talking about leading-edge erosion and how you should repair it, and it should be repaired, and how quickly it should be repaired. Those are really interesting data points, right? But I think the real critical decision is if you should repair it and how many years can you wait, right? Because it's all about spending money and spending money wisely on your turbines to keep your production power up. But there really is not a tool out there today that tells you, hey, we need to repair this turbine, but not that turbine.
Yeah, exactly. And I think what we're addressing here is this is not a new problem. Leading edge erosion, blade damages, they've been around for a long time. I also think there's been a lot of acceptance that they cause a power loss. But how you go about quantifying that in a reliable manner in the field consistently is something that, from what we see, hasn't been achieved. So we set out with the goal of kind of cracking this problem, doing it in a way that uses common data and existing data. We didn't want to go out and put this big new data requirement into the field to be able to do these kind of calculations. So it's happened quite quickly, I think, in the last few years. But I would say, a huge percentage of the installed base of wind turbines today are inspected annually, at least annually, by a drone. And the primary focus of that drone inspection has been to assess the structural condition of the blades, to look at whether there's any critical cranks and when you should fix them so you don't have a catastrophic failure. And that's super important, but there's no link to aerodynamic performance. And it's simply not good enough to say, oh, well, I've got a Cat 5 structural damage, therefore that's bad aerodynamically. It might not be. You might have a crack in a certain place that is kind of almost invisible aerodynamically, but is very bad structurally. So what we do is we take existing damage metadata, so all of the data that's captured by the drone companies, the drone inspection companies, and then we map that onto a aerodynamic model of the specific turbine in question. So, for example, if we're out analyzing a GE 1.5 or a Vestas V80 or whatever, we will have built an aerodynamic model of that turbine. So we're taking as many assumptions out of the system as we can. So we look at the real data, so the real damages that are on the turbine at that time, and it's mapped onto an aerodynamic model of that real turbine, not some generic thing.
So most wind turbine operators have a bunch of drone images and data they've accumulated over the last couple of years. So in that data set, I just want to understand this clearly here. So in that data set that the operators already have, there is metadata that describes the damages that they have on the blades, the leading edge erosion damage, maybe some lightning damage, maybe impact damage or a crack even. All that damage is metadata already in their existing data that they have purchased.
Yes, so that data exists, and that's an important thing with the system, that we can go back historically. So we'll go forward as new inspections are made, but if you want to see what has happened in the last 3 years in terms of your AEP loss from leading edge damage, we can do that because that metadata will exist. Obviously, there's differences between drone inspection providers and the level of detail, etc., but fundamentally it exists.
So I have this metadata, and I put it through the PowerCurve API, which you're calling AeroVista. So I take this existing data set I've already purchased, I send it to PowerCurve, you process it and tell me how much power that blade is losing, and what that means in terms of revenue generally. And you can do that over a trend line over the last couple of years, so I can kind of see how that blade is doing. Is it basically remaining the same, or is it really dramatically dropping off? You can tell those sort of things just from the metadata.
Yeah, exactly. And this is the great thing about using a real turbine model. What has been really enlightening when we've been adding more and more models to the system is that you could have a 100-meter diameter rotor designed by one manufacturer with some erosion on, and you could have another one that's designed by a different manufacturer that basically looks the same, on the photographs. But when you actually run the calculation, you may find that one of those rotors loses way more energy than the other. And that's because it's not just about how the erosion looks. It's about what is the aerodynamic shape of the blade. What do the airfoils look like? What's their performance? What's the stall margin? What RPM is this turbine spinning at? So again, we're taking all this into the model that is just cutting out all these assumptions that you'd otherwise have to make if you didn't build a model. So what you'll find is that even on the same wind farm that's notionally seen the same weather and it's been maintained notionally in the same way, the spread of AEP losses across the site can be quite dramatic. You may have 0.5% loss on some turbines over here, but you might have a 2% loss on some turbines over here. So again, by using the real data of each turbine combined with this aerodynamic model, it allows you to get some incredibly valuable insight as to how much money you could be losing due to blade damages. And then it can guide you to say, well, which turbine should I do something about first? Because if you just looked at the structural categorization, say you needed to pick half your fleet to repair in 1 year, you may say, oh, well, all of them have Cat 3 damages, so I'll just go out and I'll repair some of them because, I can't tell the difference. The reality is, though, that that's not a full picture of the aerodynamic behavior. It matters where that damage is, what type of damage it is. And these are all the things that we're modeling. So you can say, right, I'm going to go and fix these 5 turbines first, which they were killing me in terms of performance, and spend your money wisely, because you can't fix everything all the time. You have to prioritize, and it's a tool for prioritization.
So when I hook up your API and I go look for these losses that most operators have right now, this is a pretty quick response time, right? You're not sitting around waiting for months for PowerCurve to come back. It's like put the data in, out comes the information. You'll have it in a day or so?
Under an hour, typically.
Wow.
It's really fast. So we built this in a very flexible and scalable manner. So, we're running it in the cloud on servers that can scale. So if necessary, we can take hundreds of calls into the system simultaneously and deal with them really, really quickly. There's no hand-holding. We're not there checking, clicking buttons. This has been set up as a robust, scalable system. So the results come through incredibly quickly. So yeah, it's very, very robust, got a pretty high headroom. And now hopefully, as we grow and people start to use the system, we can scale with it. That's the beauty of these kind of modern cloud setups.
So if I'm doing a drone inspection at the end of the summer period, which we're at, right? So a lot of companies like to take them at the end of the summer or at the beginning of the springtime, just to get a status on where they are with their damage. I get all that drone information, I get the metadata, I send it to PowerCurve, and boom, within an hour, I know what I need to do for leading edge repairs. I can start scheduling people for next year now and tell them what they're going to be working on.
So instead of having to guess, well, is it worth putting on LEP, or is it worth cleaning the blade, or is it worth putting on VGs? There's all these options available to a customer, and we're hoping to just provide some insight into what is most valuable, because, LEP is not some silver bullet. LEP itself changes the leading edge shape and therefore aerodynamic behavior of a section. And depending on the LEP, that may be next to nothing, but it might not be. So if your erosion is really mild, you could use our tool. You might say, I'm only losing 0.3% LEP from erosion. Well, it's probably not worth putting on LEP from an aerodynamic perspective, because the LEP is probably in the same order of magnitude for losses. Whereas if I'm losing 3%, well, I should probably do something. But, you can then have a conversation with us about vortex generators, about LEP, about blade repair, and we'll help to guide you as to what you should do. So I think that's the thing here. Once you have a piece of data that is come from an engineering-driven approach, you can start to make much more confident decisions about how you go about maintaining your fleet and carrying out more effective asset management.
Does it also provide some information, like you could get another 0.5 percentage point in AEP by putting on VGs? Does it provide that sort of additional bonus information besides just the leading edge erosion issue?
So as of today, you get the loss. You get the loss broken down by blade as well. You'll get a heat map that shows you which of the damages are contributing most to that loss. And yeah, as we get more customers using the system, we'll enhance the functionality, but driven by what the customers want. I think, we want to get it out into the market and used. We don't want to assume what an operator wants to know. We want to have dialogues, get people using it, get the data flowing, and then we'll start adding the functionality that is most useful to the operator.
So the AeroVista API has been out for a little while now, and you've had some initial customers use it. What's the feedback been?
Very positive. I think this system as a whole started life a couple of years ago when we really started developing the engineering and the process behind how you do this. And then last year at Clean Power in the USA, we launched a version of the system. It wasn't called AeroVista at the time, but it was with SkySpecs. So SkySpecs have been a great partner in this service from a very early stage. So we launched this service with SkySpecs. So that was over a year ago now. We've run a lot of turbines through the system. And what we've seen is that it's given operators the ability to really start looking at that prioritization of repair and help to drive internal conversation about loss. Because without a number, it's very difficult to talk about budgeting O&M, VGs or LEP, whatever. So the feedback has been strong in that, yes, it is a valuable tool to prioritize. But we've also heard some interesting things that we maybe didn't latch on to straight away. And that was, well, if you have historical data, if you've got 3 years of inspection data, you'll start to see a trend. You can then start to project that forward to plan future O&M campaigns on the expectation of erosion. But then you could even take it one step further and say, well, I'm planning a brand new wind farm of this turbine type. What did I learn over the last few years on my other wind farms? And then you start to look at, very important financial decisions about, write-downs and assets and depreciation, all these kind of things. So once you've got that data set, there's a whole world of decision-making that it can open up. And I feel at the moment we're scratching the surface. And again, the more operators we engage with, I think the more we'll learn that.
Yeah, so the data analytics becomes really interesting there because it's an unexplored area of leading edge erosion, the progression on a sort of a national, even global scale with this AeroVista API tool. Yeah, you could then theoretically start projecting when a farm does certain turbines. Maybe they don't do some turbines, right? Because it may not be worth it. But it may give the industry a better sense of what is the proper timing and regimen to do leading edge erosion repair?
Yeah, and we'll start seeing patterns. We'll start seeing, are there particular turbine models that seem to suffer more than others, for example? And that could be very valuable for people making investment decisions. So I think we've got a really nice grounding in the tool. As I say, we've done a lot of work with SkySpecs. There's a lot of calls gone through the system, and that's helped us to really tune it over the last year. And now it is open to the world, where we can take API calls from anyone as long as they've had the right setup process with us. So we're in dialogue with a number of major drone operators around the world. I think, to me, in the near term, it's more likely we'll be taking calls from the inspection providers, because they're typically the ones in control of the database and the tagging and all that kind of stuff. Of course, if an operator themselves has all that data to hand and they want to go direct to us, sure. I just feel that from what I see in the industry, it's generally the inspection providers that are best placed to call us. But it's pretty operator specific, I think.
Yeah, as wind farms start to hibernate in the Northern Hemisphere, now's the time to get that drone data, start taking a look at it and figure out what the plan is for next season. I know we have seen a number of operators already planning for next year, trying to get resources lined up, because there's only so many resources out there, because you need to figure out who's going to do some of these repairs and get them booked. And now's the time that happens. Using the AeroVista API would be a quick way to help organize that for an operator, for sure.
The data's there. You've just got to use it. We're adding another stream to the decision-making process. And it's simply not good enough, in these days of challenged energy prices and contracts and, wind farm deployment. You've got to squeeze everything you can out of your assets. And that means using the data you have available. Don't throw away 2-3% AP, do something about it. But it's very hard to do something about it if it's not visible to you. And that's what I hope this tool is going to bring, this consistent, reliable methodology to give that insight.
The AeroVista API is a result of years of collaborations with local universities that help to basically define how this process works. You want to describe what happened behind the scenes there?
Yeah, so I think, PowerCurve, we're a small company, but we leverage a lot of things we've done over the years, and we're very proud to have been awarded, EU funding for R&D projects into vortex generators and leading edge erosion and other aerodynamic topics over the years. And our current EUDP funded project is called LEARCAT, or leading edge roughness categorization. So this is a project that's being led by DTU, the Danish Technical University, and then there's a number of OEM partners. So you've got Vestas, Siemens Gamesa, LM, Suzlon, and then PowerCurve, part of the consortium as well. So we're really proud to be part of that project with all of these big players in the industry, and led by such a world-renowned organization of DTU when it comes to wind energy research. So the whole idea of this project is to come up with a universal categorization system for leading edge roughness that is considering aerodynamic and aeroacoustic penalties. So I think there's this problem at the moment, like there is with structural tagging of images, that individual companies, individual operators, they have their own tagging criteria. What makes it a level 3 or a level 4? And I think that can only go on so long before the industry has to kind of come to a decision about what is the standard for tagging, because then that allows much more effective conversations to happen between OEMs, operators and service providers, and third parties such as ourselves. So over the next couple of years, LEARCAT is going to be working to do a lot of wind tunnel testing and engineering analysis, such as CFD, computational fluid dynamics, to help move us towards this universal acceptance of a classification system for damages, so leading edge erosion. So I think this is a great project. I think it's long overdue. And with the partners involved, and sort of the financial muscle of the OEMs, I think we can get a long way towards the goal and having that classification. So keep watching this space. I'm sure you're going to see LinkedIn posts and other media from the OEMs, from DTU, from PowerCurve, explaining what we're doing and why and how we're contributing to the knowledge base around leading edge erosion.
Right. And how do the operators connect up with the AeroVista API? Like, would they just reach out to their local drone company? Do they contact PowerCurve specifically? Do they hook up with you on LinkedIn? What's the process here?
So I would say if your drone inspector hasn't already spoken to you about it, then just contact PowerCurve directly, and we'll make it happen. So if you want to go through your drone inspection provider, we'll then talk to that provider. We'll have an integration process with them to make sure they know how to talk to the API. You know, they send the right file format, et cetera, the boring stuff. And then, yeah, they'll get the data pipeline plumbed in, and we're good to go. So it's a simple process. You know, it's designed to be light on input effort, but heavy on output value, and just turn it around really quickly, as we were talking around earlier.
Nicholas, you're going to be at several conferences over the next couple of months. It's a good place for anyone interested in the AeroVista API to connect with you. Where are you going to be?
So next up is Husum. So that's coming up in a couple of weeks' time, Northern Germany. So we'll have myself, CEO Niels, and my colleague Emil in business development. So we've got a good team with us in Husum. We're also having a presence in Chennai for Wind Energy India. And I think that's pretty much it for this year. And then next year, really excited about the next leading edge REFNUS symposium. It's going to be hosted by DTU near Copenhagen. And I think there's also some other AWEA events early in the year as well that we're looking at going to.
Wow. Okay. That's a great place to connect, because that way you can get your questions answered right from Nicholas. You can hear it right from him. So, Nicholas, I really appreciate you being back on the podcast. We love having you. There's just so many cool things happening in blade aerodynamics and efficiency. So it's good to get the download.